All right, guys. So happy that you're here with me today. We are going to be practicing setting up some trig functions. So last week we talked about what the trig functions are, and we started kind of getting a handle on how they work and which sides we're going to use. So we're going to do a quick review of the beginning, and then we're going to get after setting up some setting up the trig functions so we can start finding missing sides and angles, which we will do tomorrow and Wednesday. So first, I want to just remind you we have 6 trig functions. 3 of them I'm going to call my regular trig functions, and then the other 3 are reciprocal trig functions. If you haven't gotten your calculator out in a while, now would be a good time to do that. So if you look on your calculator, I have a graphing calculator, an older graphing calculator, but if you look on your calculator, you should see a sine, cosine, and tangent button. So those are our 3 regular trig functions. You will not see the reciprocal trig functions on your calculator. They can be typed into your calculator, but sine, cosine, and tangent are the quickest way to get our answers. So we're going to be really focusing on those 3 as we go forward today. But I do just want to remind you of all 6 of them. So we have the sine, the cosine, and the tangent trig functions. And when we're setting up a trig function, first of all, we have to have a right triangle and we have to have a reference angle. So that's what this theta is representing. It's representing where we're looking from. So sometimes I like to draw Bob in my picture, so that's Bob. And I use Bob to help me label my sides, because remember, our trig functions are ratios. So if Bob is standing right here, the 3 sides we need to label the hypotenuse, the opposite side, and the adjacent side. Hypotenuse is usually the easiest to find. It's always across from the 90-degree angle. Now the opposite and the adjacent side are going to be determined by where your reference angle is, by where Bob is standing. So opposite is always the side furthest away from your reference angle, so all the way across the triangle. It's going to be the side that is not making up your reference angle. So in that case, or in this case, my horizontal side is my opposite side, which means my third side, the only side I have left by process of elimination, has to be adjacent. But your adjacent side is always the side that helps make up your reference angle but is not your hypotenuse. So once you have your 3 sides, then we are going to just think about what sides will give us each ratio. So behind a trig function is always going to be the reference angle. So where are you standing? Where is Bob standing? Where are we looking from? And if you remember from this nice acronym the other day, SOHCAHTOA, this acronym helps us remember which sides go with which trig functions. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So cosine of theta, don't forget that theta, that's where a lot of people tend to go wrong. You've got to tell people what your reference angle is. And then tangent is opposite over adjacent. So these 3 trig functions, those are the buttons that you'll see on your calculator. These are the ones that we will be doing most of our use with. However, we do also have 3 reciprocal, if I can spell that right, there we go, 3 reciprocal functions. Remember that reciprocal just means you take your fraction, you flip it upside down. So if we take our sine, which is hypotenuse over opposite, and we flip it upside down, we get a new ratio using the same numbers once we have numbers, but it does have a new name, and it's called the cosecant. So cosecant and sine are always going to go together, even though your brain's going to want to put the 2 cos together, cosine and cosecant. S and C are always going to be reciprocals of each other. So if S and C are the reciprocals of each other, then cosine's reciprocal would be secant. Flip this bad boy over. And then tangent's reciprocal, this one's a little easier to remember, is cotangent. So it has the word tangent in it, so it's a little easier to remember. And then we're going to flip this guy over. Now next year when you're in Algebra 2, you will do some more work with these cosecant, secant, cotangent, and especially when you get into pre-calculus. We are going to spend most of our time focused on these 3 normal or regular trig functions. All right, so once we know how to set them up, the next piece of this, well, actually, this is kind of out of order. The next piece is going to be to set the trig functions up. Then we're going to need to know how to use our calculator so we can actually find the missing sides, but I'm going to show you how to use our calculator first. So the calculator part is a little tricky to explain only because there's different kinds of calculators. So we have two main kinds of calculators. You have a calculator like your graphing calculator, like your TI-30, those like dark blue ones. Sometimes they're green, sometimes they're pink. Those kinds, the kinds where you can see everything that you're typing as you're typing it. So if you look in my calculator, I can see literally everything that I'm typing as I type it. We have that kind of calculator where you can see it. And then you have the calculator like the TI-32 Solar, I think it is the gray one that's got like that green second button in the corner. And there's a couple other where you can only see one thing at a time. So like if you were to type in 15 minus 8, as soon as you hit 15 and then minus, the 15 disappears, and then when you hit 8, you just see the 8. So you can only see a little bit at a time. Those are going to have two different kinds of input, so how we put it in here. So it's really important that you get your calculator out and you play with it, so that way you know how your calculator works. Okay, so if we look at a triangle, I'm going to just give this one something we know. So a 30, 60, 90 triangle. So remember in a 30, 60, 90, our short leg, we can be anything we want. I'm just going to make it 2. Our long leg then would be 2 root 3, short leg root 3, and then our hypotenuse in this case would be 4, short leg times 2. So let's say I wanted to know the tangent of 30. So if you go to your calculator and you type in the tangent of 30, it's going to spit out a constant, because if you remember, the ratios are just constants. It's a fraction. So if I type in the tangent of 30, so in my kind of calculator where I can see it as I type it, I will literally type it in that order, tangent of 30, close my parentheses, hit equals, and it spits out this long irrational decimal. So it looks like we've got 0.577. If you have the calculator where you can only see small bits at a time, you're actually going to type it in backwards. So I actually will refer to these a lot as a backward calculator. So instead of hitting tangent 30, you're going to have to tell what angle it is first. So 30, and then hit your tangent button. So do that and see if you can get it to spit out 0.577. All right, so let's look at why this is 0.577. So if we use the tangent function, remembering that tangent is opposite over adjacent, then the tangent of 30 would be opposite. So 2 is opposite because it's all the way across from our reference angle. Bob's standing right here. And then adjacent is the one that's next to it. That is not the hypotenuse. So that would be 2 over 2 root 3, which reduces down to 1 over root 3. And then if I type that into my calculator, 1 divided by the square root of 3, oops, not 33, I get the exact same decimal, 0.577. So basically, your calculator has every single one of these constants for every angle you can think of saved in it. Like, you can literally type in anything. So if I type in the sine of 60, it spits out 0.866. So sine of 60. Now, if I do the sine of 60, Bob would move here, which would do what to our opposite and adjacent sides? Wouldn't that switch them? So if this now is my opposite and this now is my adjacent, that would be 2 root 3. So sine of 60 would be 2 root 3 opposite over hypotenuse, which would be, let's see, that will reduce down to 1/2. So 1 root 3 over 2. So if I type that in my calculator, the square root of 3, make sure you close your parentheses behind that, divided by 2, is the exact same decimal as my sine of 60. So your calculator will have all of these trig functions with whatever angle you want memorized, which is really awesome. So we're going to use that going forward tomorrow and on Wednesday when we're actually finding missing sides and angles. But I just wanted to make sure you know how to start using your calculator. All right. So today we're going to focus on just setting them up. We're not going to focus on the calculation part. Setting them up is probably the most important part because it doesn't matter if you can solve it if it's not set up right. So we're going to focus on picking a trig function and then making sure our ratios are correct. So here is our first example, example A. So we've got a right triangle where we know one angle measurement, we're looking for two side lengths, we know one side length. So anytime you are given an angle measurement, that's what you want your reference angle to be. So I'm going to put Bob right here. Now we can very easily find this top angle by doing 180 minus 90 minus 54. But I always say use the one that you're given in the picture, because if you accidentally make an arithmetic mistake here, and let's say you think that that's supposed to be 66, and it's not supposed to be 66, then when you set your trig function up and solve it, because you made a mistake here, you're going to have wrong answers everywhere else. So I always use the angle that I'm given. So 54 is my reference angle. So if Bob is standing here, I'm going to label my sides. So X would be the opposite side because it's all the way across from Bob. 9 is your hypotenuse. It's across from your 90-degree angle, which leaves Y as our adjacent side. Now we're going to have to set up two trig functions, one to find X and one to find Y, because if our goal is to find X and to find Y, which we'll be doing tomorrow, having X and Y, having two variables in the same equation isn't going to do us any good. So if we think about finding X first, since we don't know Y, it is not going to be helpful at all, so I'm going to ignore it. So we need to look at this. I have the opposite side and the hypotenuse side. Those are the two sides that are going to help us. So if I think about my SOHCAHTOA, I'll write it down here again so I don't have to keep moving my paper. Which trig function uses opposite and hypotenuse? So that's the sine, opposite and hypotenuse. So sine of our reference angle, where we're standing, equals opposite over hypotenuse. Now we actually could set this up using a reciprocal function. So we still have the opposite and the hypotenuse, but if we had set it up as 9 over x, instead of it being sine of 54, it would be the reciprocal, which would be cosecant of 54. So either one of these would be a great way to find x. However, our calculator does not have a cosecant button, and since it has a sine button, we are going to focus mainly on our three regular trig functions, but this is still okay. All right, so let's think about y then. So y is the adjacent side, means x is not going to help us, so I'm literally going to cover it up. So adjacent and hypotenuse would be adjacent hypotenuse, that would be cosine. So cosine of where we're standing, of our reference angle, equals adjacent over hypotenuse. It has to be in that order, so y over 9. And again, adjacent and hypotenuse is also secant if we reciprocal the fraction. So we could use the secant of 54. We would just flip our fraction over 9 over y. So this is still correct, but going forward, we don't have a secant button, so the cosine is going to be the probably the most straightforward way to find it. All right, let's look at example B. So 22 is our given angle. We can very easily find this angle measurement by doing 180 minus 90 minus 22. But if we already know that this is 22, we can make the 22 our reference angle. So I'd like for you to pause the video and see if you can set up a trig function for A and set up a trig function for C. All right, so once we have figured out where our reference angle is, we're going to label our sides. So 12 would be the opposite side, C is our hypotenuse, and A is our adjacent side. So to find A, hypotenuse isn't going to help me because that's another missing side. So opposite and adjacent is tangent. So we're going to have the tangent of 22 equals opposite over adjacent. So that's what we're going to do to set up A. You could use the cotangent function here as long as A was on top and 12 was on bottom. And then to find C, we're going to ignore A. So opposite and hypotenuse, that's sine of 22. Don't forget your angle measurement, your reference angle, and that will be 12 over C. All right, let's look at example C. Now, if you look at example C, what do you notice? So this time, we have two missing sides, and we're looking for two missing angles. Now, first of all, if I wanted to find side C, would I need a trig function? Well, if this is a right triangle, couldn't we use the Pythagorean theorem anytime we have a right triangle to find a missing side? So just because we're talking about trig, don't forget all of the other ways that you know how to find missing sides and angles in a right triangle. So we could use the Pythagorean theorem here. Okay, so we're going to focus on theta and alpha though. So theta and alpha are in two different places, which means we're going to have two different reference angles. So we're going to have to think about this a little bit differently than we were thinking about finding missing sides. So it doesn't matter which angle you find first. I'm going to start with theta. So I'm going to put Bob right here. Now if I put Bob there, I'm going to label my sides. So we've got opposite, adjacent, and hypotenuse. Now, since we don't currently know what C is, we don't know our hypotenuse, it is not going to be helpful. Now, if we find C using the Pythagorean theorem, we can totally use the hypotenuse to help us write a trig function. However, I wouldn't use it only because if we make a mistake here, then it's going to give us a wrong answer for theta. So I like to always use things that are given to me in the picture. So if I don't use the hypotenuse, then I have opposite and adjacent. So SOHCAHTOA. So opposite and adjacent, that's tangent. So we would say tangent of our reference angle. So this is really important since we have two different angles we're going to be looking for. So tangent of theta is where we're standing. Opposite has to go on top over 19. So that's how we're going to find theta. Now alpha, once we know theta, we could just subtract to find alpha, but at this point we don't know how to solve it, so we're going to need to set up a second trig function. I would only caution you about that like when we start doing this on Wednesday. Once you find theta, using theta to find alpha, I'm just caution you against that because if theta is wrong, then alpha will be wrong. But if you set up a trig function for alpha that does not rely on theta, then you have a chance to get it still right even if theta is not right. So if I want to find alpha, I have to move Bob. So Bob has to stand over here. So what happens if Bob moves? Do any of our sides change? Well, hypotenuse will always be the hypotenuse because it's always across from the right angle, but won't the opposite side and the adjacent side be switched now? Because opposite of alpha now, all the way across from alpha, is the 19. So in this case, we're going to have to switch these bad boys. So here's opposite now and adjacent. So hypotenuse still isn't going to help me. Opposite and adjacent is still tangent. This time alpha looks like a fish. So tangent of alpha, and then that would be opposite, which is 19 over 22. So I'm using the same trig function, but my angle is different, and you can see that my fraction is also different. Now you may look at this and notice like, oh, this is 22 over 19, it's the reciprocal, so why didn't we use cotangent? Well, the reason it's not cotangent is because it is not the same angle measurement. So if we look over here, tangent and cotangent are reciprocals when we're looking from the same angle and our fraction is flipped over. This time, although we have the same, or we have the reciprocal, we're looking from two different angles, so it's not going to be the reciprocal function. All right, so I want you to take a second. We're gonna have you pause the video again and see if you can find a trig function to find A and to find B. So instead of having an alpha and a theta in here, you're going to use A as your missing angle. So maybe you'll say the tangent of A or the sine of A, and you're going to use B as your missing angle. So tangent of B or sine of B or cosine of B. So pause the video and see if you can set up a trig function for those. All right, so depending on what you want to do first, most people like to go alphabetical order. So if we find A first, here's Bob. So opposite would be CB. Adjacent would be AC, the 12. And 22 would be our hypotenuse, AB. So let's see, which side's not going to help us? Opposite doesn't have any information. So SOHCAHTOA, we've got adjacent and hypotenuse, so that will be cosine. Cosine of A, so where Bob is standing, where our reference angle is. Adjacent on top, 12 over 22. Now this can be reduced, and so you can reduce it, but in a couple days we're going to be solving this to find a, and the reducing of it won't really matter. But if you'd like to reduce it, you can reduce it over to 6 over 11. All right, and then we're going to move Bob to find angle B. So I'm going to move Bob down here, which is going to switch these two guys. So Bob's moved, opposite, adjacent. So 22, adjacent was not going to help us this time. So opposite and hypotenuse is sine of B. Make sure you change your angle measurement. And then opposite, 12, 22. Now this is interesting. We have the exact same fraction this time, but notice that we have two different trig functions and two different angle measurements. So sometimes you'll notice that sine and cosine will use the same fraction, but you will also see that the angles will be two different angles. All right, so if you try your homework and you still have questions, or if you still have questions on the notes, please reach out to Miss Regal or myself. We'd be happy to help you. Otherwise, have a fantastic day.